The coin toss lottery was a very simple one. In that lottery, we only had two outcomes, and each outcome was equally likely to occur. So now I want to go through a slightly more complicated lottery, the one that we already calculated the expected value for, and for this lottery, using the same utility function that we did for the coin toss lottery, I want to calculate the utility of expected value and the expected utility. So here is the table containing the more complex lottery, and it has the three columns that you're already familiar with. On the left-hand side, we have the probability of each outcome. Then we have the X column, which is the payoff for each outcome. Next to that is the column that multiplies each probability times the payoff, and at the bottom of that column we have the expected value, which is equal to 125. Remember that the utility function for our gambler is u of x is equal to the square root of x. And so when we find the utility of the expected value, all we're going to do is take the expected value of $125 and plug that into the utility function. That means to find the utility of expected value, we will be taking the square root of 125. That is equal to about 11.18. So if she were to get a guaranteed payoff of $125, her utility level would be 11.18. Now let's calculate the expected utility. Notice that what we're going to do here is find the utility for each payoff in the X column. We're going to find out how much utility would our gambler get for each payoff. So if the payoff were $25, we would find the square root of $25 because that tells us her utility for that payoff. And the square root of $25 is 5. If she were to earn a $100 payoff, her utility would be the square root of 100, or 10. If she were to earn a $400 payoff, then her utility would be 20. And if she were to earn a $900 payoff, her utility would be 30. Now we look to the far right-hand column, which is the probability times each utility that she could receive. And we're going to populate that column by multiplying each utility by its probability. So 60% times 5 gives us 3. 25% times 10 gives us 2.5. 10% times 20 gives us 2. 5% times 30 gives us 1.5. And now we're simply going to sum up all of those products in the far right-hand column, and that is going to give us the expected utility. If we add those values in the right-hand column together, we can see the expected utility is equal to 9. An expected utility equal to 9 means that if the gambler were to play this lottery over and over again, her average utility level per play would be 9. We can see that in this lottery the expected utility is less than the utility of the expected value. In other words, this gambler would get more utility out of a guaranteed payoff of $125 than she could expect to get by playing this lottery. Therefore, as with the coin toss lottery, she would prefer the guaranteed payoff. What can all of this tell us about risk preference? Well, remember that the utility of expected value, u of e of x, tells us how much utility someone would get from a guaranteed payoff. Expected utility, e of u of x, tells us how much utility the same person would get from playing a particular lottery. Now there are three logical possibilities here. One is that the utility of expected value is greater than the expected utility. In other words, our gambler gets more utility from a guaranteed payoff than she does from playing the lottery. In this case, we would say that the gambler is risk averse. The simple explanation is that she values the money that she might lose in the lottery more than she values the money she might win. The next possibility is that the utility of expected value is equal to the expected utility. In other words, she gets exactly as much utility out of a guaranteed payoff as she does playing the lottery. In this case, we would say that the gambler is risk neutral. We could say that this gambler values the money she might lose exactly equal to the money that she might win, and so she's really indifferent between her two options. The third and final possibility is that the utility of expected value is less than the expected utility, that would mean that she would get less utility out of the guaranteed payoff than she would out of playing the lottery. Such a gambler would be called risk-seeking. This type of a person values the money that she might win in the lottery more than she values the money that she might lose. Now, empirically, most people are risk-averse. There are some risk-neutral people out there, and a very small minority of people are risk-seeking. But for this class, we're going to assume that consumers are risk-averse and firms are risk-neutral.